We are asked a very basic question. What is the probability it will take a new customer longer to go through a lambda A equals 1, lambda S equals 2, MM1, than a delta equals 1, PA equals 1/3, PS equals 2/3 Bernoulli single server queue? Well, we're not told the exact setting, but for proper comparison, it would be natural to assume steady state of both queues. It would also be natural to assume independence between the queues, so we're not biasing or trying to make one behave in a certain way compared to the other. If we weren't told anything else, those would be the assumptions we would always take. The customer times for the MM1 and the Bernoulli single server queuing processes in steady state are: the MM1 is a lambda S minus lambda A, in this case 1 exponential. The Bernoulli single server queuing process customer time in steady state when delta is equal to 1, denoted by TSSB, and the probability mass function for TSSB is A with some constant, which we will give below, times Q, another constant, times 1 minus Q to the n minus 1, plus 1 minus A PS, 1 minus PS to the n minus 1, and that's good for n equals 1, 2, 3, 4, etc. So as we know, it takes at least one time frame to flow through a queue, hence we start with n is 1. Here, Q, according to our theorem, is PS minus PA over 1 minus PA, and in this case, with PS being 2/3 and PA being 1/3, that'll just be 1/2. And A is 1 minus PA over 1 minus PS. Again, in this case of PA and PS, A will be 2. So we can simplify this probability mass function for TSSB, n, to be 1/2 to the n minus 1 minus 2/3 times 1/3 to the n minus 1. That's just substituting in the values of PS, A, and Q. But we can simplify this further, and with simple algebra, this turns out to be 2 times 1/2 to the n minus 1/3 to the n. Now we wanted to express that in terms of n because we're going to get an expression for the MM1 also in terms of n. So we wanted to simplify that in terms of n. So now we can move to our desired probability. The probability that the customer time for the Bernoulli single server queue in steady state is less than the customer time for the MM1 in steady state. Well, that by total probability is the sum n equals 1 to infinity of the probability that the MM1 in steady state is greater than n, given the Bernoulli single server queuing process steady state time is n, times the probability of that TSSB is equal to n. Notice we partitioned over the values of the BSSQ steady state because that is the one that is discrete. Now, since the MM1 is independent of the Bernoulli single server queuing process, the conditioning on the Bernoulli single server queuing process time TSSB goes away. And so we're left with a sum n equals 1 to infinity of the probability that TSSM is greater than n times the probability that TSSB is equal to n. Well, the probability that TSSM is greater than n is just this 1 exponential, so that's just e to the minus n, so we can substitute that in. And up above we have the probability mass function for TSSB, so we just state that here. And then we can combine these two equations by substituting in the probability mass function for TSSB, and we get that the probability that TSSB is less than TSSM, i.e. the steady state customer time for the Bernoulli single server queuing process is strictly less than that of the MM1 steady state customer time, is equal to 2 times the summation n equals 1 to infinity of 1/2 times e to the minus 1 all to the n, or simply 1 over 2e to the n, minus the summation n equals 1 to infinity of 1 over 3e to the n. Well, we can keep the 2 out for a moment, and then we can recognize that we have geometric sums. An infinite converging geometric sum is evaluated as the first term over 1 minus the step size. For the first geometric sum, that is just then 2 times 1 over 2e over 1 minus 1 over 2e for the first term, and then minus 1 over 3e over 1 minus 1 over 3e. So if we multiply that first term by 2e top and bottom, and the second term by 3e top and bottom, we wind up with 2 times 1 over 2e minus 1 minus 2 times 1 over 3e minus 1. Then we can just simplify that to 2e over 2e minus 1 times 3e minus 1. And that works out to be approximately 0.1727.